Good morning, children. Today we will be starting with chapter 13, surface area and volumes. As an introduction, let me give you a review on plane figures, curved figures, and so on. Figures which you can draw in a piece of paper are called plane figures. A few of them are rectangle, square, circle, and so on. A rectangle has two dimensions, that is length and breadth. A square also has a length and breadth, but length and breadth are equal. So we say that edge of a square or a square has the same dimensions for length and breadth. Similarly, a circle has radius. And now these are the figures which are two-dimensional, and we call them as two-dimensional figures. They have two dimensions and we call them as two-dimensional figures. That is why we were finding the perimeter and area of these figures. Imagine you cut out many rectangles of same size and you stack them in a vertical pile. Imagine what will be the shape formed. The shape formed will be a three-dimensional solid, because there will be length and breadth, and since it is a stack with a vertical pile, there will be a height also for this particular solid. So the solid formed is called a cuboid, which has three dimensions of length, breadth and height. So what will be the solid formed with the cutouts made with square? We call it as a cube. A cube also has three dimensions of length, breadth and height, but the peculiarity is the length also, breadth also and height also all will be of the same measure. What will be the three-dimensional solid formed by circles or circular cutouts? It will be a cylinder with radius, and there will be a height formed for this cylinder. Let us represent a cuboid. A cuboid will have only rectangular faces. This will represent a cuboid where this length will represent the length. Whatever be this length will represent the breadth, and this length will represent the height. Thus, a cuboid will have 6 rectangular faces. There will be 12 edges. Edges are the lines where the faces meet. If you take a tissue box, that will give you a clear example of what are the faces of a cuboid, what are the edges of a cuboid, and wherever the edges meet, there are 8 vertices. The vertices are formed where the edges meet. They are points. The vertices are points. Edges will be line segments. and the faces will be rectangle shape. See, the vertices with the points, edges with the line segments, and the faces will be rectangle shaped. And now similarly, so how do you represent a cube? If there are only square faces, the solid formed is a cube. Same way as cuboid, a cube also will have 6 faces. Here all faces are equal in measure. That means the edges will be of same measure. Then there will be 12 edges. Edges are all line segments, and there will be 8 vertices. The vertices are points. So they are the 3D solids. Let us derive the formula for surface area of a cuboid and cube with the available material with me. The example of a cuboid is a tissue box or geometry box. Any of the boxes with the dimensions as length, breadth and height will represent a cuboid. When you see here, this tissue box, the length is from this vertex to this vertex. Then that means this line segment represents the length. Then the line segment from this vertex to here, that is, this line segment represents the breadth and this line segment represents the height. That means there is length, then breadth and height. And now, what is the meaning of surface area? The word area itself is very clear that it is related with the plane figures you know. The faces are made up of rectangles. There are 6 faces. And what are the peculiarity of the faces? Opposite faces, that means a face on the top and bottom are equal. The face, this face as well as the face here are equal. The face here and the face here are equal. At the same time, they are rectangles. So, surface area is the sum of all these areas. That means you find the area of the first phase, second phase, third phase, fourth phase, fifth phase and the sixth phase, and if you sum it up, that will give you the surface area of this solid. Here, since there are 2 equal faces, what is the area of this particular face? The area of the top face is length into breadth. That is length into breadth plus the same equal area at the bottom, another LB plus. What will be the area of this particular face? It is made up of length and height. That means there is LH plus one more LH on this side. Again, what will be the area of this small face here is breadth into height plus BH plus BH, which give you the total of 2LB plus 2LH plus 2BH, or what is the formula for total surface area? That means you have the surface area of 6 faces. Total surface area is 2 into LB plus BH plus LH. The total surface area of a cuboid is twice LB plus BH plus LH. Similarly, if you take the example of a cube, the available material with me, this is the solid representing a cube. If you see the edges, there are 12 edges, but all the edges are of equal length. There are again 6 faces. All the faces are of square shape. Normally we take the side of a square as A. What is the area of one of the face? Area of a square is side into side. So A into A. So the surface area is A square. The first face is A square. There are 6 faces. Either it is 6 times A square, or if you consider this way, A square plus A square plus A square. 6 times, that means 6 faces will give you the total surface area of a cube as 6A square. We call normally as total surface area as the short form TSA. That means the TSA of a cuboid is 2 times LB plus BH plus LH, and TSA of a cube is 6A squared. Now imagine any room in your house with the walls having the dimensions of a rectangle, excluding the windows. Now, if you want to paint the walls, normally we do not consider the floor and the ceiling of our particular room with the same paint. This particular concept is called as the lateral surface area of a cuboid. That means if you have the dimensions of only 2 LH plus 2 BH, you call it as the lateral surface area, or only the area in the lateral faces. That means for any solid, if you exclude the face which is on the top as well as the face which is below, you call that surface area as lateral surface area, or short form is LSA. So LSA of a cuboid you can very well compare with area of 4 walls of a room. Area of 4 walls of a room, and the formula will be the base as well as the roof that will be excluded, which gives you the formula as 2LH plus 2BH, or 2 times LH plus BH. We will just derive one new formula as, if you take out H as common, it will be written as 2H into L plus B. Again by arrangement, we will make it as 2 into L plus B into height. And what is 2 into L plus B for a rectangle is perimeter. That is perimeter into height of the room. That is, the LSA of a cuboid is the same as area of 4 walls of a room. The formula is perimeter into height. That is 2 into L plus B into height, or you can remember it as 2LH plus 2BH. For a cube, the lateral surface area will exclude the faces of the top as well as below. There are 6 equal faces. Area of one face is A square. Therefore, what will be the area of the 4 faces? It will be LSA of a cube is 4A square, because you are considering only the lateral faces of the cube. You are excluding the top as well as the base of the cube to get the lateral surface area. What is the unit you will be using for surface area? Now, unit as well as conversion table is very important in all subjects, and since the word related is area, you can always understand that the unit will be either centimeter square, meter square, kilometer square, or any square units. Now, what is the meaning of a conversion table? In most of these exercises, you will have to convert the dimensions into the same unit. To remember this, you can understand the conversion table as the units under consideration is millimeter, then the next unit is centimeter, the next unit is decimeter, the next unit is meter. Let's go forward as decameter, hectometer, and the next unit of kilometer. How to convert is whenever any of these smaller units, if you have to convert into a higher units, it is, you can understand that a smaller unit is only a part of a higher unit, and so you will divide by the powers of 10. That is, you will either divide with the 10, 10 square, 10 cube as per the number of units you are shifting. And when you have to convert from a bigger unit to a smaller unit, naturally you will multiply with whatever be the powers of 10. That means as many places, I am not writing 10 here because moving from the smaller unit to a greater unit, you will divide, and from a higher unit to a smaller unit, you will multiply with 10 to the power of as many places as you are moving. Let me give you an example of convert 5 millimeter to decameter. If you see here as 5 millimeter to decameter, millimeter to centimeter, centimeter to decimeter, decimeter to meter, and meter to decameter. That means the movement of 1, 2, 3, 4 places to the right shows that 5 by 1, 2, 3, 4, which is the same as 1, 2, 3, 4, 1, 2, 3, 4 decimal. That means 5 millimeter is the same as 0.0005 decameter. If you want to convert 5 hectometer, I am purely avoiding the units you know already. 5 hectometer to decimeter to decimeter. What you will do is, you know that hectometer to decimeter is from a higher unit to a smaller unit. How do you convert? Is 1 hectometer will turn to decameter, meter, decimeter. That means 1, 2, 3 places. That means 5 into 1000, 5000 decimeter. If you understand the concept in this, it will be very helpful to you even in your other subjects. Copy this conversion table in your notebook with the example so that you can refer it again and again. Exercise 13.1, we are proceeding. Before starting the exercise, while doing surface area, you have to read and understand the question, because sometimes we may have to adjust the formula according to the question. That means if a solid is given with a box of rectangular shape or a cuboidal box without cover, you have to adjust the formula in such a way that the surface area of the faces required are calculated. Now, the first question. A plastic box, 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. The units are very important. So, exercise 13.1, first question. A box. Since length, breadth and height is mentioned, identify it as a cuboidal box. So, length is equal to 1.5 meter, breadth is equal to 1.25 meter and height is equal to 65 centimeter. Immediately both the dimensions are in meter, so height also convert into centimeter. The basic is millimeter, centimeter, decimeter, meter. That means the centimeter to meter conversion is divided by 100, which is the same as 65 by 100 meter or 0.65 meter. Now, is to be made. It is opened at the top. That means the top portion, that formula you need not consider. So, what are the faces here? There is the base area of LB. The remaining 2LH plus 2BH is there. Ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box. So, you cannot say the total surface area or lateral surface area. You have to use the word surface area of the box. Or what is the area of sheet required? Area of sheet required to make the box is equal to, instead of 2LB, you have to take only the base. That means LB plus 2LH plus 2BH. You have to substitute the formula as L into B, that is 1.5 into 1.25 plus 2LH, 2 into 1.5 into 0.65 plus 2 into BH, that is 1.25 into 0.65. The multiplication as you just multiply what is 125 into 15. 5 5s are 25, 12, 6, 1 5 is 5, 2, 1. 1875. There are 1, 2, 3 decimal place. So you move it as 1.875 plus 2 into 1.5 is 3. Or if you want it the other way, you can multiply 15 into 65, 25, 30, 3, 975 into 2. 5 2s are 10, 15. Finally, you are getting 1950. How many decimal place? 1, 2, 3. That means 1.950 plus again 1.25 into 65. 125 into 65. 8,125 into 2. That means 16,215. How many decimal place? 1, 2, 3, 4. That means 1.6250. How do you add them? 1.875, 1.950, 1.6250. 5 plus 5, 10. 7 plus 2, 9 plus 1, 10, 15. 9 plus 1, 10, 18 plus 6, 24, 2, 2, 3, 4, 5. So the answer is 5.45 meter square. Why I am showing in a detailed way is this is a scoring lesson. You should not lose mark by careless mistake of removing either the decimal place or by getting the multiplication wrong. The next is the cost of the sheet if the sheet measuring 1 meter square cost rupees 20. How do you present the statement as cost of 1 meter square sheet is equal to rupees 20. Therefore, cost of how many meter square you are using? 5.55 meter square is equal to, again the same way, 5.45. You just multiply 545 into 20. You can avoid 2. You can multiply or with the 20 also, because the answer should not be wrong. 0, 0, 0, 5 2s are 10, 9, 5 2s are 10, 0, 0, 9, 1, 0. Now how many decimal place? It is 1, 2. That means rupees 109 is the final answer. You just do it systematically so that the answer will not be wrong. Question 2. The length, breadth and height of a room are 5 meter, 4 meter and 3 meter respectively. Length is 5 meter, breadth is 4 meter, height is 3 meter respectively. It is a room, underline the word room. Find the cost of whitewashing the walls of the room and the ceiling at the rate of rupees 7.5 per meter square. It is similar to the previous sum, because not even the walls of the room, they have taken the base, they have taken the ceiling also. So, area to be painted, you can use the statement like area to be painted is equal to LB plus 2LH plus 2BH. If you want, not like the previous problem, you can take common factor outside as LB plus 2H into L plus B, and then you can substitute the value as L into B, 5 into 4. Once you are thorough, you can do all these calculations by taking the common factor outside. Plus 2 into height is 3 into length plus breadth is 5 plus 4, which is the same as 20 plus 5 plus 4 is 9. 2 into 3, that means 6 into 9, or 20 plus 54 is equal to 74 meter square is the area to be painted. Now what is the cost? At the rate of rupees 7.5 per meter square. So cost of 1 meter square, cost of painting 1 meter square is equal to rupees 7.50. Therefore, cost of painting 74 meter square is equal to 74 into 7.50. You need not take the 0 here. You can multiply 74 into 75. It is 5,550, and then you have not taken the 0, that means one place. That means it is rupees 555. Question number 3. The floor of a rectangular hall has a perimeter 250 meter. That means perimeter of the floor is equal to 250 meter. If the cost of painting the 4 walls at the rate of rupees 10 per meter square is rupees 15,000, find the height of the hall. That means, what is the formula for LSA of a cuboid or area of 4 walls of a room? As I explained to you, area of 4 walls can be finally reduced as perimeter into height. So here, area of the 4 walls of the room is 250 into H. That is the area of the 4 walls of a room. Now, what is the question says is, if the cost of painting the 4 walls at rupees 10 per meter square is rupees 15,000. So, with the same formula, you can write cost of painting 1 meter square is equal to rupees 10. Therefore, cost of painting 250 h meter square is equal to 250 h into 10. That is the cost. Understood? But if the total cost is given as 15,000, total cost is given as rupees 15,000. So how do you equate it? 250h into 10 is the same as 15,000, or what is the height of the room? 15,000. Don't multiply here because it will get simplified. Now in class 9, this is the procedure. You will not multiply. Wherever you see simplifications, final answer only you multiply. 0, 0, 0, 0. You can see here with the table of 5, 5 5s are, 5 3s are, or 30 into 5 is equal to 6, or the height of the room is 6 meter. This concept, please understand, cost of, you just found the area of the 4 walls. You found the cost, the total cost is given to you. Just equate so that you will get the missing dimension of height.